So when we talk about packed bed, we need to consider a few different types of definitions, basic definitions. And a big thing here is the definition or notion of porosity. So porosity, you can think of it as, empty space within a given finite volume, right? So when in the example of this packed bed reactor, so each CSTR, you can imagine packing this finite volume with some sort of pellets, right? It could be sphere, it could be cylinder, but when you pack this volume with those pellets, obviously there's going to be interstitial spaces, meaning there's going to be empty space between these pellets, because even if you're using spheres, there's going to be gap between different spheres. So we need to somehow account for that. And there's external porosity and internal porosity. So external means basically everything outside of the pellet. So we're considering pellet as impenetrable solid. So there's no volume inside. That's empty. So it's solid pellet. And then we're just considering the volume outside of pellet, but within this volume. So basically, the bed porosity is the void space between the actual this tank finite volume and then whatever's outside of those solid pellets. However, in reality, there's internal porosity, right? Because each pellet has pores, because those are just pellets are made out of binders aggregated with different adsorbent materials, and adsorbent materials are powder materials. So when you make these pellets synthesize and produce, there's going to be porosity, and there's going to be total internal porosity, which is represented as epsilon p. But then you can kind of think about the epsilon p as the combination of macropore and micropores, right? And inaccessible volumes, but for the sake of modeling purposes, we can assume that inaccessible volume is 0. So you can just combine the macropore, which means just larger pores, and micropores, which means more pores that are smaller. So we need to account for this internal porosity as well in our model. And there's different types of density, right? So you consider the total mass of adsorbents within a finite given volume, and then you divide by the volume of that finite volume, then you get a density with respect to the bed. And with respect to pellet, you can also define the density, right? Because the total mass of the adsorbent would be the same, but instead you're taking account for this 1 minus epsilon b, which is, you can think of it as the volume fraction of the bed, right? So it's the volume occupied by the pellet, and you're adjusting the total volume of the bed with this volume occupied by pellet. So those are basic definitions that are useful to understand when we start playing around with the our toPSAil simulator.